Good morning. Welcome to Technology Takes the Wheel, the third in our speaker series for autonomous vehicle seminars. And we are just really very honored to have you all with us here today as we explore the topic of infrastructure, security, and vehicle considerations for autonomous transportation. My name is Debbie Franklin, and I work at Wichita State University in Strategic Initiatives. Again, we are honored that you were prioritizing this for today as we work with industry experts to understand this emerging technology and how it will all affect our lives, affect each of our lives. The first in our series, as you may remember, we did back in August of last year. We did an overview of the autonomous vehicle market at that time. We followed it pretty quickly in October, on the 11th of October, with the second in our speaker series, where we talked about human mobility and impacts on autonomous vehicles. We were scheduled to run our third series, this particular event, back on January 31st. And there's been a disruption globally that has caused us to be delayed, but we are tickled to come back and visit this very important subject. And today's seminar, again, is Infrastructure, Security, Vehicle Considerations for Autonomous Transportation. We have with us today four fabulous speakers. We have Rebecca Steele, who is with Toyota North America. We have Josh Van Weisenberg, who is with Automotive Systems Engineers from AAA. And we're very honored to have had AAA work with us through this entire series. They've been enormously valuable and delightful partners to work with. Michael Barnett, who works with Smart City Coordinators from right here in Wichita, Kansas, and Randy Barth, who is from Topeka, Kansas, with the 3M Transportation Safety Division. So we welcome to all four of our speakers. Before I turn this over to our good partner, Sean Stewart with AAA of Kansas, I did want to take just a minute to thank our technical expert, Maddie Dumbo, who has helped us to transition from in-person meetings over at NCAT to this online format. So many thanks to Maddie. And also I want to thank Felicia, who has been our moderator for all three of these events, and we're grateful to have her with us again today. But none of this could be possible, absolutely none of this could be possible without our partnership with AAA of Kansas, and our good friend Sean Stewart, who has been shepherding this forward, helping us to identify wonderful panelists like we have today, and helping us to organize our thoughts as we all explore this emerging market. So at this time, I'd like to pass it over to Sean for his opening comments.
Thank you very much, Debbie, and thanks to your excellent team at Wichita State for being such wonderful collaboration partners on this seminar series. We're pleased to bring you this third edition of our Technology Takes the Wheel seminar series, highlighting the future of connected and autonomous transportation. You may wonder why AAA is involved. As the nation's foremost advocate for motorists and travelers for nearly 120 years, road safety is a big priority for us. Also important is making sure that AAA members and all motorists are aware of and educated on policies, trends, and technologies that may impact them. And make no mistake, autonomous or self-driving vehicles will at some point be on our roadways and will affect everyone in our society. We have an excellent lineup of speakers today, as Debbie mentioned. And to get us started, I'd like to introduce you to our moderator, Felicia Rolfe. Felicia is anchor and a reporter for KWCH 12 Eyewitness News, the CBS affiliate in Wichita. And she has moderated our two previous events, and we're so thrilled to have her here today to walk us through this presentation. So again, on behalf of AAA and our 60 million plus members across North America, I want to thank you all for joining us again today. And I'll turn the mic over to Felicia now.
All right, thank you, Debbie, and thank you, Sean, and of course, thank you to Wichita State and AAA Kansas for presenting these seminars, looking at the future of our transportation system. So interesting. I love them. Well, in our two previous technology takes the wheel systems seminars, we provided a glimpse of the future possibilities of self-driving vehicles and shuttles and what they may bring to our communities. We also discussed what states and localities are doing in planning for these transportation innovations. We also highlighted the human and mobility impacts of autonomous vehicles. Now, in today's seminar, we will delve further into the topic, discussing the interactions of complex, robust transportation infrastructure, secure cybersecurity systems, and the advanced vehicles that will make up this transportation transformation. We have a great lineup, as you already heard from Debbie, so let's get right to them. Our first speaker is Rebecca Steele. Steele is Director, Emerging Technologies Policy for Toyota Motor North America in Washington, D.C., where she has responsibility for a variety of policy issues, including vehicle security. She previously served in the Senate for over 5 years for U.S. Senator Ron Wyden of Oregon, the Senate Finance Committee, and Wyden's 2016 re-election campaign. She graduated from the University of Portland, Oregon, and holds a master's in communications from Johns Hopkins. Rebecca?
Hi, thank you so much. Thank you, Felicia, and thank you to AAA and Wichita State for putting together this fantastic panel today. And to tee off of what Sean said, some point, hopefully in my lifetime, we're going to have autonomous vehicles on the roadway, and conversations like these are extraordinarily important to helping our transportation system and ecosystem be ready for them, and the public as well. So today I'm going to be talking about the cybersecurity policy landscape here in the United States, and how we secure our vehicles in order to secure consumer trust. Next slide, please. So why is the policy landscape important? Now, if you know the policy landscape, as any good lobbyist will tell you, you're going to be able to plan and you're going to be able to anticipate the changes that your business or your city might be ready or needing to make. Today I'm going to talk about how that vehicle security policy landscape is shaping up in the United States, and then move forward into what the trends are going to be in that space and why all this matters to bringing technologies like autonomous vehicles onto the road. So when we take a look at this graphic, it's one that many folks might be familiar with. You often see it in U.S. Department of Transportation press releases talking about connected vehicles. And it really showcases how connected infrastructure is going to be working with one another. You can have the city bus that's talking to the vehicles, that's talking to the stoplight, that's talking to the pedestrian. All of this in the name of efficiency and also public safety. Now, in order to get to this point where we can reach public safety by using these advanced technologies, there's people that are involved. And I'm not just talking about the people that are the security engineers or the driver of the bus, but the people that are walking down the street, the people that are a passenger in the car, the people that are maybe buying an autonomous vehicle. And in order to want to partake in that advanced technology, consumers have to trust that technology. Next slide, please. And so vehicle security is a really important part of building that trust. And when you secure a vehicle, you're going to give the consumer a more trusted environment and a higher willingness to use those advanced technologies. Now, right now, a recent survey found that 3 out of 4 Americans don't think that automated vehicles are ready for prime time. So 3 out of 4, 75%. However, there's some good news on the horizon. Drivers who regularly interact with or have advanced technologies in their cars, like automated cruise control, blind spot monitoring, lane assist, they are more likely to trust an AV in the future. So everything that we're doing now in advanced technologies and vehicles is helping to build that consumer trust so that there will be adoption of these critical technologies as we're moving forward. And vehicle security is a really key part to adopting customer trust, because if they don't trust these systems, they're not going to use them, and we're not going to realize our goal of a safer, more efficient, higher quality transportation ecosystem. Next slide, please. So what does the policy landscape look like for vehicle cybersecurity in the United States? And I mentioned that this is important because policy really sets the foundation for how companies are going to be thinking about how do we secure our vehicles, how do we make sure we meet the standards, and what are others in the ecosystem going to be doing? How can we ensure that there's trust among the ecosystem? How are we all working together towards a common goal? And policies help set that precedent and set that common baseline as we move forward. Now, in the United States, we have a puzzle of various different pieces that come together to form our policy around vehicle cybersecurity. This includes regulations, guidance, legislation, best practices, and international standards. So I'm going to delve into just a few of the key ones that relate specifically to automotive. Obviously, there's many standards in the world, much guidance, many best practices when it comes to cybersecurity of all types of systems. And we, of course, at Toyota and other manufacturers turn to those, as well as these ones specifically for automotive systems. So I'll be focusing on the automotive systems ones today. Next slide, please. So an important thing to remember, and this is a little bit unique in the US, is that currently there are no federal cybersecurity regulatory standards that apply to passenger vehicles. Now, that doesn't mean, as I mentioned, there's all these other parts of our puzzle that come together to form vehicle cybersecurity, but there is not an FMVSS that specifically addresses cybersecurity. So what are these other parts? What is this guidance? What are these best practices? What are the standards that we're looking to? Next slide. Thank you. So when it comes to guidance, this is some of the kind of seminal guidance that we look to from our federal agencies here in the United States. So first we have the FTC. They, of course, regulate claims that we make about vehicles or any product that a company might build. They've also put out guidance for securing the Internet of Things, much of which could be applicable to the transportation ecosystem or the vehicle. We have the seminal work of NIST, the cybersecurity framework, which really is foundational to how we approach securing all systems at Toyota, including the vehicle. They just updated that version 1.1 to include supply chain management. And so that is something that is constantly referenced within the automotive vehicle security space, and something that is a building block for building out a vehicle cybersecurity program. We also have AV guidance. This is the fourth version of it coming from the Department of Transportation. There's a section of it that's focused specifically on cybersecurity and how the public and private sector can come together. And again, that kind of sets the tone and the approach that the United States is going to be having towards vehicle cybersecurity, and is very, very collaborative with the public and private sector, recognizing that the private sector is oftentimes the one seeing the threats every single day and combating them. Now, finally, we have cybersecurity best practices for modern vehicles. And this is guidance that's released by NHTSA. And again, this expands more on the DOT and the US federal government's approach specifically to vehicle cybersecurity. This is non-binding guidance. It's been worked on very closely at NHTSA with collaboration from stakeholders from across the transportation ecosystem, manufacturers, safety advocates, suppliers, cities, states. So it's a great place to turn if you're looking at how NHTSA is approaching and thinking about cybersecurity when it comes to vehicles. Because a cybersecurity issue could be deemed a safety defect depending on what exactly that cybersecurity issue is. So it's important to understand what NHTSA is going to be looking at when it comes to vehicle cybersecurity. Next slide, please. We also have best practice guides that have been put together by the industry. And the best practice guides that are primary for vehicle cybersecurity have come through the Auto ISAC. Now, the Auto ISAC, for those who aren't familiar with ISACs, is an information sharing and analysis center. And ISACs are formed across a variety of industries. There's ones for aviation, there's one for financial services, one for ICT, critical manufacturing. And the goal of an ISAC is to pull together all of the stakeholders in that ecosystem in a secure environment where they can develop best practices, share information. That's really key. It's right there in the name, information sharing, what they're doing with that information on threats, and help to raise the level of security for the entire industry. So the Auto ISAC was formed in 2015 to do that for the automotive industry. Toyota was a founding member. And one of the things the Auto ISAC has done is put together best practice guides to guide OEMs and suppliers and others that are part of the value chain when they're thinking about securing the vehicle and the ecosystem. And some of these best practice guides include on risk assessment and management, governance, awareness and training, security development lifecycle. There's 7 of them total. And if you're interested in seeing them, please feel free to shoot me a note and I can send you the link where they all live. They are open to the public. So like I said, these are developed by the automotive industry. They're forward-looking guidance. They aren't prescriptive. It doesn't say you should use this exact protocol to secure this ECU. Rather, it is like the cybersecurity framework. Here's a framework that you can then plug into, and you can figure out how to best utilize this in your environment. Next slide, please. And finally, we have standards. Like any good company, there is a myriad amount of standards that we look to when we're building up our approach to securing our vehicles and really securing all of the systems across our company, whether it's enterprise or operational technology or the vehicle itself. These are 2 that are specifically focused on automotive cybersecurity. So that's why I call them out here. I'm not an engineer. I'm a policy person. And so I'm pointing these out to you because this is going to be informing policy that's happening in the United States, because these are international standards that global companies are going to be looking to and are going to be following when they're building cybersecurity into their vehicles. So we have ISO 21434 that's in draft form, and it should be finalized this year. And then SAE J3061, which is already out there. And so those are 2 specific to automotive vehicles. I encourage you to take a look at them if you want to see where US policy and global policy really overall is headed when it comes to vehicle cybersecurity. Next slide. So we look back at these kind of 3 types of guidance that we have, these 3 pieces of our puzzle that come together to form the US approach to vehicle cybersecurity. There's some key themes among them that has worked well in the US and for automakers that operate at a global scale. First, they're non-prescriptive. As I mentioned, it doesn't say this is how you do this. It says this is the goal, and these are tools to reach the goal. You want to have your information be confidential. You want to ensure the integrity of it. You want to ensure access is only given to certain people, things like that. But how you achieve that goal is going to be evolving, to the second point, as threats evolve and as security best practices change. Our threat environment is constantly changing. So are the ways that we mitigate risk within our ecosystem. And then finally, and this is really key, and this is where the public-private partnership comes in when it comes to vehicle cybersecurity, good policies encourage information sharing. The motto of the ISAC is an attack on one is an attack on all, because our ecosystem is so connected to each other. An entry point through a stoplight is an entry point into potentially the head unit of a vehicle, depending on how things are configured, right? And so we want to mitigate that risk as much as possible. And in order to do that, we need to share information about threats, about best practices for designing the systems. And really, this has come together in the form of standards, right? We have common interests as an industry, and we're working together in these global fora to develop standards around vehicle cybersecurity that we can then follow and really raise the level of security for our entire ecosystem. You are only as secure as your weakest link, and we want to build a community of defense so that we can help raise up the security of everyone who participates in the connected vehicle ecosystem. Next slide. So the road ahead. Now, these are 3 specific areas that are going to be coming up within the next year, right? And this is where you want to look towards, I'm planning, I'm thinking about what cybersecurity is going to look like for the vehicle. I'm just interested in how we're going to secure these vehicles because I want to build consumer trust and have them adopt the technology. These are 3 areas to keep an eye on. One, that NHTSA best practices towards cybersecurity that I mentioned earlier in my presentation. That is going to be updated, and a version of that should be released very soon. The Deputy NHTSA Administrator, James Owens, spoke this week to the Auto ISAC at our annual summit, And his words were very soon. I suspect it will be coming within the next few weeks. So keep an eye out for that from NHTSA. They're going to be submitting it to the public for comment. So if you have an interest in vehicle cybersecurity, a business interest or a public safety interest, please take a look at it once that comes out. Second is legislation. Legislators like to legislate, and they share a similar goal as we do of keeping Americans safe and ensuring that there's an environment in the US where we can benefit and capitalize on the advanced technologies that are being pulled together. Some areas of legislation to keep an eye on and some specific pieces. There's legislation moving around securing Internet of Things devices at the federal level. That's important because a vehicle interacts with different IoT devices, and in fact, there might be IoT devices within the vehicle. We have the AV Start and Self-Drive Act. These are the federal AV bills that we've been really trying to push forward for a couple Congresses now in order to have a framework so that we can deploy automated vehicles here in the US and really realize their potential. In those AV bills, there's a requirement that auto manufacturers have a cybersecurity plan. So keep an eye on those as they're moving and iterating next Congress. And then finally, there's UNECE WP29. And essentially what you need to know about this is that they're UN standards around automotive cybersecurity. Parties who've agreed to the UN agreement are going to be implementing those standards next year. While the US is not a party, we of course have global companies operated in the US that sell products around the world. And so we'll be looking at those standards to inform what we're doing around vehicle cybersecurity policy here in the United States. And I suspect lawmakers and regulators will be looking to them as well. Next slide. So 3 broader trends that I want to end on to get your mind thinking a little bit past, the first year, next year of the next Congress. So the 3 trends are data, labeling, and supply chain security. Now, these trends are not unique to the automotive industry. They're trends in tech policy in general, but they're going to have impact on the automotive industry and vehicle cybersecurity, which in turn will impact the entire ecosystem. So when we talk about data, we're thinking about who has access to the data. Is that access provided securely? What are consumers' privacy rights surrounding that data? And how are we implementing data management as manufacturers, as cities, as states, and as really anyone, any third party that's interacting with the transportation environment. Labeling, as I mentioned, securing the Internet of Things is a really important topic right now. Oftentimes, those little baby monitors, connected toasters don't have great levels of security. And so setting a baseline for those Internet of Things, the cybersecurity baselines, the minimum standards that they should hopefully meet, and then creating some sort of labeling regime around that so customers can understand the security of the device that they're buying. That is an emerging trend. While that trend of labeling should not apply to complex cyber physical systems like a vehicle, it is certainly going to impact how consumers are thinking about all the devices in their world that connect to the internet. And then finally, we have supply chain security. This is nothing new to this space. We are always looking at the security of our supply chain, but we are now looking at policymakers on both sides of the aisle who are increasingly interested in the security of the supply chain for national security purposes. And so you're going to see more import and export controls around key technologies, hardware, software, emerging and foundational technology that we use to secure our vehicles. And so ensuring that we're able to still secure our vehicles under an increased level of scrutiny around import and export control on those technologies is really important. And then as an OEM, it's also important for us to be able to look up and down our supply chain and figure out how we can better secure our entire supply chain. We have tier 1, tier 2, tier 3 suppliers, third-party vendors. And so we're all working together to figure out how do we ensure security of that entire supply chain. Next slide. So finally, I'll leave you all with my answer to this question of why vehicle cyber policy matters. And it matters because we want these advanced technologies to be adopted. This is the Toyota LQ, the level 4 vehicle. It has AI built in. It's an EV. This is the type of vehicle that we want in the future to provide mobility for all, to have us be a cleaner, safer, smarter streets. And in order to realize this technology, we have to have good policies that lead us to good vehicle cybersecurity. So this is why this matters. This is why I believe it matters. And hopefully it's given you something to think about when you are hearing lawmakers or other folks talk about vehicle cybersecurity. What are the things that we value as an automaker that help us secure our vehicles? So thank you. And my understanding is that we're going to be taking questions at the end of all the panelists. So if you want to put your question in the chat box, I'm happy to answer it then. You can also shoot me an email. My email's right there. I'm happy to share any of the resources that I ran through today.
All right, thank you so much, Rebecca. Very good presentation. So interesting to learn all about cybersecurity. You mentioned questions, so we are going to take those at the end. But right now, we're going to look at another quick question we're going to put on there just for a moment. What is the most common entry point for automotive cyber attacks? So if you want to enter your answer on the screen, folks, you can do that. We'll tabulate the results in real time, and we can share those results for you in just a moment. We're going to give you a few minutes to do that. And just think about what Rebecca was talking about a moment ago. Cybersecurity, why it matters, makes sense. We have to have good policies. And so interesting that she said that 3 out of 4 people, 75% do not think we're ready for driverless vehicles. That's very interesting. So I know you're learning a lot, as I am today. Don't forget to go ahead and tabulate in on this poll. What is the most common entry point for automotive cyber attacks? Might not be what you think it is. Were you listening to the report? Okay, so let's go ahead and give you the answer. The answer is C, keyless entry fob. Is that what you thought it was? All right, moving on now. So our next presenter is Josh Van Rensburg. Josh comes to us from AAA National Headquarters in Heathrow, Florida, where he is an automotive systems engineer. Now, since joining AAA in 2014, Josh has been an integral part of several high-profile research projects focused on emerging vehicle technologies and advanced driver safety systems. Van Rensburg has led research projects on issues ranging from fuel quality to testing of level 2 driver assistance technology. He has also spearheaded the development of AAA's strategy in the area of vehicle data analytics. And he has also worked for prominent organizations such as Bombardier Recreational Products and John Deere. He holds a degree in engineering from the University of Central Florida and a master's in model-based systems engineering from Georgia Tech. Folks, welcome, Josh Van Rensburg. Hey, Josh.
Hi. Thank you, Felicia. Rebecca did a great job illustrating the legislative aspects to an autonomous vehicle deployment. I'm going to step back and walk you through some of the technical aspects related to AV sensor systems and cybersecurity. Next slide, please. Traditional vehicles require the driver to perceive the environment and make thousands of decisions related to the operation of the motor vehicle. Whether the driver realizes it or not, they're making many decisions, even when navigating a route they've driven countless times. The driver is required to navigate, obey traffic signals, monitor surrounding traffic, adjust the vehicle speed, and even turn on the headlights and wipers when the situation requires. When we transition to autonomous vehicles, the vehicle still has to make all of the same decisions, but it has to perceive the environment through sensors and communication to external networks. AVs require precision GPS so they can accurately navigate streets and position the vehicle accurately at stoplights and maintain their position within the lane. The vehicle also has a network of high fidelity cameras, radar, LiDAR, that continually map the surroundings and transmit the data back to OEM data servers. So changes in the route, such as new road construction and obstacles in the roadway, can be incorporated into the high definition maps. Next slide, please. Autonomous vehicles utilize surround view cameras to detect and classify objects like the image shown on the left. By classifying objects, the vehicle can make intelligent decisions, such as waiting at the light for a pedestrian to cross the street or slowing down for a vehicle in the roadway. While cameras are beneficial, they have limitations in certain conditions, such as direct sunlight or heavy snow. LiDAR sensors use laser to continuously measure and map the surrounding area, such as the image shown on the right. It's easy to see how autonomous vehicles can generate massive amounts of data based upon their sensors. Intel estimates that autonomous vehicles could generate nearly 4,000 gigabytes of data per day. Cameras and LiDAR sensors alone can generate 100 megabytes of data every second. As a result, autonomous vehicles must be able to transmit large amounts of data back to data centers, which makes connectivity crucial for AV deployment. Next slide, please. The automotive industry is rapidly evolving and is set to exceed 80 million vehicles in operation with embedded cellular connectivity by 2022. Industry leaders such as Ford, Hyundai, and Toyota will have 100% of their new vehicles built with embedded connectivity by the end of this year. With embedded connectivity, automakers are able to collect sensor data and driving data from vehicles to make informed decisions about product design and predictive maintenance. Autonomous vehicles will rely heavily on embedded connectivity to communicate critical vehicle information to data centers so engineers can monitor systems and possibly remotely control the vehicle in the event of a failure. It's easy to see how cybersecurity is becoming a major concern as more and more vehicles are built with embedded connectivity. Next slide, please. According to a recent upstream cybersecurity report, the number of automotive cybersecurity incidents has increased dramatically over the last 10 years. In the past year alone, the number has doubled. As millions of connected vehicles hit the roadway, the potential for a serious cyber-related incident increases exponentially. Cybersecurity is not only a major concern for vehicles currently on the road, it's a major concern for data-intensive autonomous vehicles that do not have a driver behind the wheel. Next slide, please. This relates to the previous poll question. Automotive cybersecurity is a complex topic since there are numerous ways for hackers to get in, which is known as an attack vector within the industry. Not only can hackers get into company data servers to steal confidential information, they can gain entry to vehicles through keyless entry attacks and even control a vehicle remotely from anywhere in the world. The most common attack vector for hackers is defeating the key fob that many cars use for keyless entry. Hackers often target critical company servers and databases in ransomware attacks, where hackers take control of critical computer systems and demand the company to pay ransom, often in the millions of dollars. Next slide, please. Automotive cybersecurity incidents are increasing at a rapid pace. So who is responsible for these cyber attacks? We know that researchers, students, and cybersecurity companies typically test systems, which is known as penetration testing. These ethical hackers are considered white hats since they're attacking automotive systems in an effort to find bugs. Unfortunately, in 2019, black hats committed the majority of automotive cyber-related incidents, and this trend is expected to increase in coming years. Next slide, please. Automotive theft is big business, with the FBI and the US estimating that the crime costs Americans over $6 billion a year in more than 700,000 separate vehicle thefts. While keyless entry systems are convenient for motorists, they're also making it easier for criminals to break into your vehicle without causing damage. A key fob is designed to transmit a radio frequency code a short distance, typically around 3 to 4 feet. So when you approach the vehicle, you can open the door with just your touch. Hackers have found that using a simple signal booster like the one shown on the left, they can extend the signal over greater distances. The image on the right depicts criminals using a receiver to boost the signal of the key fob in the house while his partner waits to unlock the door and start the vehicle. AAA's partner in Europe, the ADAC, tested 237 vehicles and found that 230 of those vehicles, or 99%, could be fooled by a simple relay attack, which allows a vehicle to be stolen. Next slide, please. One of the primary motives of an automotive cyber attack is financial gain. Another motive for hackers is simply to disrupt traffic and cause mayhem. Spoofing is a type of cyber attack where the vehicle is tricked into a response that is not intended or desired. The speed limit sign on the right might look normal at first glance, but researchers were able to fool a Tesla into accelerating to 85 miles per hour by placing a small piece of tape on a 35 mile per hour sign. In the image shown on the left, a cheap outdoor projector was used to trick an automated driving system into stopping for a pedestrian that wasn't actually there. A more complex example of spoofing required research teams to trick the vehicle's GPS into following a different path than desired. These types of cyber attacks pose a great risk for autonomous vehicles since there are many methods and they're easy to deploy and cost relatively little money to carry out. Without a driver behind the wheel, how will autonomous vehicles respond to this type of attack? Next slide, please. One of the most frightening types of cyber attacks is that when a hacker is able to take full control of the vehicle from a remote location. In 2015, researchers demonstrated they were able to hack a Jeep Cherokee computer by going through the vehicle's infotainment system wirelessly. The researchers were able to control every aspect of the vehicle from the radio volume to activation of the wipers and headlights. In addition, they demonstrated the ability to remotely steer the vehicle into a ditch and override control of the brakes, which resulted in a slight crash for the unsuspecting occupant. This demonstration highlights the true vulnerability of autonomous vehicles and the importance of secure data connectivity. Next slide, please. As we can see, cybersecurity is a major consideration for the safe implementation of autonomous vehicles. So what is the industry doing to combat this challenge? AAA participates in automotive industry groups such as SAE and AutoISAC related to automotive cybersecurity to help define best practices to improve vehicle security from the ground up. In addition to AAA's government relations group working directly with policymakers to ensure strict standards are in place for the safe deployment and testing of autonomous vehicle technology, AAA's automotive engineering group also conducts research on a variety of advanced driver assistance systems, which I'll show you in a few slides, in an effort to improve future system functionality and safety. Next slide, please. Automakers, Tier 1 suppliers, and mobility companies routinely sponsor bug bounty programs, which pays ethical hackers if they're able to find an exploit in the software and to provide background information of how they uncovered the issue. Ford and General Motors have over 1,000 resolved bug reports completed through this type of paid program. This is a small price to pay for improved security, since a true cyber attack could cost the automaker hundreds of millions of dollars to resolve. Next slide, please. Not only does AAA participate in automotive industry groups related to cybersecurity, we also routinely test advanced driver assistance systems through a variety of real-world test scenarios. AAA's engineering team has evaluated ADAS systems such as automatic emergency braking, blind spot monitoring, Level 2 automated driving, and pedestrian detection systems. These systems are the building blocks for fully autonomous vehicles, And AAA is right there working with automakers to ensure they understand the findings from our research. Next slide. And that's all I have today. And if you have any questions, we can answer those in the time available at the end. Thank you.
All right, thank you so much, Josh. For folks, I guess we probably won't look at our key fobs the same way we used to anymore now, will we? We didn't know that they were so vulnerable to things. All right, so we are now halfway through the lineup of our presenters. So we want to take a brief, short intermission, just a little break to allow everyone a chance to check your email, grab another cup of coffee, some juice, some water, and we'll resume at, let's see, 10 o'clock Central Time. Or actually might want to do, we're going to take 5 minutes. We're a little early, so maybe we'll come back at 9:50. Does that sound good? And so we will be ready to go again at 9:50. Be right back. And we're back. Is everyone ready to go? Hopefully everybody had a chance to get some coffee and drink water, just a short little break, maybe grab a snack. And we hope you're enjoying the seminar today. Remember, we're going to have this on the website for you as well at Wichita State, as well as the past seminars. There are 2 more previous ones. You might want to check those out as well. Okay, we've had 2 presenters already this morning. We're moving on with 2 more. And then remember, we're going to take questions for you at the end. So start thinking about those and send them to our chat box. So our next speaker is Michael Barnett, the Smart City Coordinator for the City of Wichita. There, he drives digital transformation across the city under the direction of city leadership. Barnett is responsible for smart city and connected community initiatives and projects within the city. He also chairs the Wichita Innovative Living Lab, a smart city lab focused on bringing meaningful technology and closing the digital divide to residents of Wichita and complementing Wichita's smart city program. His focus is on economic development, public safety, process improvement, and technology integration. He has a bachelor's degree in environment studies from the University of Washington and master's in science from the University of Southern California. Please welcome Michael Barnett. Michael?
Thank you, Felicia, so much. And thank you for moderating this panel. And thank you, Debbie and Sean, for everything you guys have done. It's been wonderful to be here. So, well, so far in this presentation conference, we've heard about cybersecurity. I'm going to take us on a slightly different road and talk about what it looks like for a city in terms of our perspective for autonomous vehicles and what we're having to do to prepare for autonomous vehicles from companies like Toyota, and what impact that has to our residents and to our policies and the foundations for how we plan and design the city itself, and how that all comes together. Go ahead, next slide, please. So first thing I'd like to mention is that the first stage of autonomous vehicles that are going to be hitting the streets are relatively dumb. And what I mean by this is that they are not autonomous in the truest sense. They have no sense of autonomy. They cannot make their own decisions. They rely on connected vehicle infrastructure. They rely on communication between other vehicles, and they rely on communication from the infrastructure itself to make decisions, which means that we have to do our best to ensure that all of the different foundational pieces of this technology are in place long before we see the average resident driving these vehicles on our roads. So when you talk about a human operated vehicle, we depend on many different things to make decisions. An autonomous vehicle doesn't do that. So we need to make sure that we have a new form of technology in place at a city side that can enable the autonomous vehicle to truly function well. And what this looks like is a complete overhaul of the traffic system that's currently in place. Now, a city like Wichita has over 600 traffic signals in a 164 square mile area. It is a large, sprawled out city with residents of extremely different opinions on this technology and on different opinions about most things. But when we start talking about this process, we've already begun that here, at least in the city of Wichita. And some of the surrounding communities have as well, as has our KDOT, who was a previous speaker in another one of these panels earlier last year, I guess. So one of the things that we're doing in a city is we have to take all of those traffic lights that we know and depend and basically rip out all of their current guts. And we have to put in a new traffic controller that now is intelligent, quote unquote. And what that means is that traffic controller is able to take in disparate information from sensors, from cameras, and from vehicles to make decisions as to when to change lights, as to when to green light certain vehicles through, like emergency vehicles, and how it operates with other traffic lights in coordination. So that brings the question down to, you've replaced the guts of traffic signal, but now we have to do something about the sensors. And the sensors is one of the most important things that the city has to do to ensure a really good rollout for these vehicles. Is we have to be complementary in the way that we do this with the way that vehicles are doing it. So, you heard earlier about LiDAR and radar, cameras, et cetera. And then for the infrastructure side of this, it hasn't changed very much. We're going to be doing roughly the same thing, and we're going to be supplying all that information back to those vehicles. Go ahead and do the next slide, please. So when a city does this process, one of the things we need to be fiber rich. And what that means is that a city has to have a lot of fiber optic cable. It's the main backbone for internet communications across any form of way that you receive it, whether that's from your cell phone, which have fiber to the tower, or to your house, which usually has fiber to the street, if not fiber directly to the home now. And then we have like radio and cellular, which are huge. 5G is going to play a huge role in this as that continues to be developed. The biggest difference between 5G and 4G technology for autonomous vehicles is their ability to have almost no discernible latency to a computer. Now, to you and I, that's a couple of seconds, even up to a whole second, actually rather, like milliseconds to a whole second of latency before we'll really start to notice an issue as we watch things. But to a vehicle, nanoseconds matter when it comes to latency. 5G and the way that technology has been developed has that low latency approach. And so for a city to truly be able to roll out autonomous vehicles in numbers, we need to make sure that we have 5G technology throughout the entire city. And that's the vehicles will primarily use to get a lot of their data in and out. A lot of the other data that they're going to be using is things like DSRC, which is a car vehicle to vehicle and a vehicle to infrastructure only protocol that shares information about where it's at, what it surrounds, and the way that it's being driven, how it's braking, how fast it's accelerating, and information like that. Now we have various sensors, and part of the issue with sensors is that there is no right answer. Every city is going to have to go through this trial and error process to determine what works best for their city for themselves. In Wichita, we found out very quickly that traffic cameras do not work well here. The dust that comes off of the surrounding farms and the surrounding rural areas is so extreme here that it requires cameras to be cleaned on a regular basis. And so we began looking at things like LiDAR sensors and radar sensors because they do not have that issue of maintenance. Now there's even talk about using thermal sensors from a company like FLIR to begin predicting where people are at and pedestrian movements. For the longest time, most sensors were in the ground. They were magnetic, basically coils that were buried under the road right in front of traffic signals. And when your car ran over them, they would trigger a on-off response until the signal that a vehicle was waiting. That has a lot of problems. It doesn't tell you how many cars are there and what directionality those cars are necessarily going, or any information about their drive at all. And so we've been looking at different methods for this. Go ahead and go to the next slide. So here's two different examples. Now the one on the left is actually the city is putting in across the board. These are Wavetronic smart sensors. These sensors are able to see 900 feet in either direction, or in the direction of facing rather, and they're able to read between 6 and 8 lanes of traffic. Now we have these positioned all over the city of Wichita. If you're local here, you can drive down Maple Corridor and see them up, as well as Rock Road and areas like that. And they're constantly being rolled out. The entire downtown area will start to see these relatively soon. On the right is the newer technology. It's the FLIR Traffic One system, and it's mostly aimed at pedestrians, and it's using infrared to be able to monitor where people and dogs, strollers, etc. are, and feed that information back to traffic signals. Truly, this is the biggest and most critical point of difficulty for a city, and every city is going to have to go about this in their own way. one of the biggest problems for this is that these sensors are extremely expensive. And for cities, it's going to entirely depend on the size of their budget, how much traffic signals they have, and how spread out they are for how they're going to do this. Wichita's focused on its downtown area first because it's the area that gets the most change in traffic density and movement. And so when you look at these sensors, you know, the city is going to be relatively upfront and be able to do this long before the suburbs and the rural areas are going to be able to accomplish this. But one of the difficulties this presents for autonomous vehicles is a patchwork of design. Some cities will be way ahead of the curve, like Ontario, Canada, which has a massive amount of infrastructure deployment, has huge companies backing them. They are well ahead of the average city in terms of development for their infrastructure. And then you have cities that are going to be slower on that adoption rate. And that's going to create a difficulty for vehicles and how they drive through cities on their own and how they respond to things like pedestrians and traffic congestion and other issues that are going to come up if we do have that patchwork of technology. And there is not any standardized viewpoint yet for how to deploy smart sensors, for when cities should be doing that, or even a infrastructure-based communication protocol. We're using DSRC, but there's no federal body that's stated that DSRC is the way to go forward with this. Go ahead, next slide. So when you talk about ITS design, we go through a lot of different debate on this. My traffic engineers here in the city, who are ultimately in charge of our entire traffic system, have the firm belief that we're not going to see any autonomous vehicles within the city of Wichita within the next 10, 15, maybe even 20 years in terms of capacity. Capacity is usually a number of around 20% of vehicles as autonomous before we've reached what we're seeing as capacity. Personally, I think this is a flawed viewpoint. I equate this very much to the nascent stages of cell phones in the early 1990s, mid 1990s. Only 1.82% of people had cell phones before the big thing like smartphones came in and basically forced universal adoption overnight. We haven't seen that stage of autonomous vehicle technology where it truly takes that leap forward from a nascent stage to that intermediate stage where people are going to want it and accept it and have it rolled out. What we do know is that people in urbanized areas want it more than others, and people who are have university degrees and tend to want this kind of technology more because they value the benefits that it gives. They value the savings in life, the savings in environmental degradation, as opposed to the loss of freedom necessarily by being able to just hop in the car and drive where you want to drive with you behind the wheel as the ultimate decision maker. When we talk about this ITS system design now, there is a road controller in every single design, as well as having the intersection controller. Now, you generally have like a roadside unit that monitors exactly what's occurring on the road. You have wireless communication backhauling that. And then you have like a either surface mounted or non-surface mounted nodes that feed that sensor information back. The city is not using in-ground nodes any longer. We are only using light pole attached radar, LiDAR, and occasionally camera-based sensors. One of the best examples of this that we have today is Tokyo. They have an amazing traffic control center. You can see it there on the left, or the right, my apologies. They've had that there for many, many years, oddly enough, and it is massive and wonderful. And they're able to control every single signal remotely as the need arises and route traffic. It's a fully manned and staffed center 24/7, 365 days a year. It's a true traffic control center. Wichita has a very, very minor stage of that. We call it Whichway. It's located in downtown Wichita. And we don't have nearly the overview or the control that, say, somebody like Tokyo has. But once again, Tokyo has a greater need. It's the most populous city on earth. And they have a lot of backers there. Rebecca, who was on the call today earlier, Toyota is from Toyota. Toyota is actually based out of Tokyo for their international side. And there's a lot of movement there in terms of development and research. So that facility makes sense there. Does it make sense in Wichita? Probably not at this stage. Next slide, please. So when we look at connected autonomous vehicles, you guys heard some numbers before. They have the power of 20 modern PCs, 100 million lines of code, and 25 gigabits of data. A lot of that data is coming back to the city in some way or some fashion. Our traffic controllers have to digest that data to make decisions. There are different ways that we can set up traffic controllers to proceed to make decisions. You can have them so that they determine to follow set schedules, which is a very old school way of doing things, or you can have them do it in a more ad hoc, intelligent way where they take that information from vehicles and they analyze it, and then they broadcast those decisions back out. Problem is that we don't have a way of necessarily getting all that information back into the city. 25 gigabits of data per hour per vehicle is enormous. Luckily, they don't actually send it much back to us. They send a much smaller amount of data. But even a modern traffic controller using the highest end of logging and ability to make decisions can send up to a terabyte of data a day back to the city. And we've got 614 of those signals, which that number fluctuates daily. And so it's very difficult to determine how we're going to handle that influx of data, how we're going to control it, and how we're going to keep it safe, which is why it's so important to have people like Becca and Josh and the industry experts here who can help us in terms of the city guide that path forward, not just on the vehicle side, but on the infrastructure side to keep that data secure. Automotive vehicles will change the way that we look at driving, will change the way that we look, or automated vehicles will change the way we look at vehicles and the way that we drive them, the way that we operate them. When a company used to design a vehicle, they were very clear they designed it first and foremost for the operation of the vehicle, then for basically user comfort as things developed. But today they're developing it first for communication to the outside world. In the next slide, go ahead and go. I noticed that nobody so far had shown some of what this looks like. This is just a standard connected car. This isn't an autonomous car. This is a standard connected car. And you can quickly see that it's almost as much computer as it is car. And that's fairly amazing. When you talk about the more modern, recently invented vehicles, they can have dozens of cameras pointing out directions on all sides, ultrasonic sensors to measure how close they are to curves or the vehicles, the radars, the cameras, and so on and so forth. These vehicles become more and more like computers per day. And similar to that, our traffic controllers and our traffic signals become their own independent little cloud computing networks, little computerized locations. And so that every single traffic controller and traffic signal on the road is becoming more or less its own independent computing powerhouse. And they don't just handle traffic anymore. These signals are now being used for dozens and dozens of things, primarily policing, oddly enough. If you go into any of the major cities in the country, you're going to start seeing basically, thinking of the acronym, I'm not thinking of the word, my apologies, but license plate readers on these infrastructure points to read license plates, report that data back to an system so that they can tell whether or not you have warrants out for your arrest, whether or not you have unpaid parking tickets, and so on and so forth. They monitor the ingress and egress of traffic throughout the city, how people are coming in and how people are coming out. All of that data is being collected. The problem is not a lot of cities are using the data in a cohesive way. And so until we get better at that, we've got a lot of growing room to do. Data is one of the biggest concerns that faces any modern city today, and the way that they both keep and capture data and the way that they then utilize data that's coming in and coming out. We do have cities that are facing pressure to monetize the traffic data that's coming in. A lot of cities already do this. They sell the data from their traffic controllers back to third-party companies, like your local neighborhood grocery stores, to measure how much traffic goes by to help them make decisions on where to put the next grocery store, or to how to sell better based on the value of the cars that are going through the area. Go ahead and go to the next slide. So we talked about the dumb vehicles, and to me, a dumb vehicle, what's missing is that connectability to other vehicles and to the infrastructure. And the first vehicles that are truly hitting the road today are dumb. They do not possess the ability to really communicate amongst themselves, nor do they have the ability to communicate to infrastructure in a good way. What we'll see when a vehicle becomes quote unquote smart is that ability to communicate in a near latency free manner. And they'll communicate between every vehicle, every infrastructure point. They'll be able to monitor where pedestrians are and where cyclists are, and report that data not just back to themselves, but back to surrounding vehicles, even vehicles that aren't necessarily autonomous, but other connected vehicles, to let you as a driver, if you're not driving an autonomous vehicle, know that, hey, there's a cyclist on your right. Now, one of the most dangerous stage of autonomous vehicle rollout in a city is during the seminal phase, where we're going to have a mixture of autonomous vehicles and normal driven vehicles all together on a road at a time. And the reason this is dangerous is because, quite frankly, humans were not built to drive vehicles. We are not as good at making decisions in a moment. We miss things, and we can't always stay as alert as we should be on the road. And little tiny things like cell phones play such a huge distraction that we fail miserably. And I'm definitely no exception to this rule. And so when we talk about autonomous vehicles, they don't have that issue. They are always aware. They're always functioning properly. They never decide to drive drunk. They never decide to speed. They never decide to drive recklessly because they're in a hurry. They will always go the pace that's safest for not just the driver, but the people around them. And that brings up one of the larger concerns that's not being discussed right now, is how we determine ethics in a vehicle. There is a debate currently regarding that point, but we'll get there eventually. And what I mean by that is, how to use a vehicle determines the trolley problem of yesterday, where if the vehicle has to save the driver's life or 5 people's lives on the side of the road, what decision does it make when it's autonomous? And that decision has not really been evaluated or even reviewed yet. So when we look at these vehicles right now, we're talking about communication, talking about the way that they function, but we're not talking about how they're truly going to operate independently from a driver's control. And right now we do rely on level 4 vehicles, which must have a driver always aware of what's going on. But the true dream is level 5 and beyond, where the driver is removed from the situation, and me as a driver could sit there and take a nap, drink my morning coffee, and watch the news, play some video games on the way into work or the way into anywhere, because I'm not needed to drive that vehicle for commuting. That's the beauty of level 5. But it's going to take a lot of work, not just on the OEM side, but on the city side, to get us there. One of the things that can change that rapidly is true artificial intelligence. Go on to the next slide, please. So we lack artificial intelligence. Just flat out, hate to be a basher on this word, but it's one of my personal pet peeves. There is no such thing as artificial intelligence in any application whatsoever right now, because it implies autonomy and it implies intelligence. It doesn't exist. What we do have is machine learning. Machine learning is just a very rudimentary form of AI in which you're able to use trend analysis and other forms of data modeling to make decisions. Autonomous vehicles truly rely on data modeling and data trends to make decisions. They look at information from programmed into them to make decisions on what they should do next, but they don't take into account things that they've learned or into cues of their surroundings. So, even right now, the biggest debate, one of the debates currently is what these vehicles should be called. Are they automated vehicles, are they self-driving vehicles, or are they autonomous vehicles, or are they connected autonomous vehicles? Connected autonomous vehicles implies that form of communication and to each other and to the infrastructure. But automated or autonomous implies that they're able to self-drive. The difference between automated and autonomous is the ability to have autonomy, the ability to change the way that the way that you are able to make decisions on your own. Autonomous vehicles cannot make a decision on their own. They can only make a decision that was programmed to them. Therefore, they are automated. They're not autonomous, truly. So that brings us to this sort of other problem that cities face today, is that because these vehicles cannot make a decision on their own, how are we going to integrate them into a society that's used to driving based on sort of more emotional intelligence as well as that actual physical motorized skills intelligence? A driver today uses emotional cues. When they see somebody wave them forward at a stop sign, when they see a pedestrian waiting, they know whether or not they should go or whether or not they should proceed inside the city. Even a parking lot can be a terrible hazard for an autonomous vehicle as it's currently designed, because we lack the ability to truly predict that. Currently, most autonomous vehicles and connected autonomous vehicles are programmed to always defer to pedestrians, to just stop the vehicle or slow down to allow a pedestrian to cross. That can quickly become a problem in cases like jaywalking, because people will always take the shortest path. And they'll just go ahead and basically skip along and rely on that vehicle to stop for them. And so these things are problems that we're still working out, and we'll rely on our co-developers in this space, co-conspirators in this space, to determine the best ways to handle this moving forward. And that makes the best CAV for the choice a big deal. And that's the next slide. Go ahead and go to the next slide, please. So we have a lot of different types of connected vehicles in design right now. The city of Wichita has been working to bring an Ollie or Navia style shuttle, which is a transit support type vehicle, to the city for a number of years now. You can see one of those in the upper right hand corner of the screen. That's the Ollie. Mike Tan, our transit director, talked about it briefly a little while ago. London actually just rolled out the first autonomous full-size bus, which is the bottom one. You can see there's various different designs here. On the far left is one of the cooler designs that I personally think, and it's a vehicle that's basically changeable to what is currently on it, from a personal vehicle to an RV style vehicle to even a carrier for lumber, etc. So CAVs have a lot of opportunity that we just don't have, and I'm really looking forward to seeing the way that they move forward in this. Go ahead and go to the next slide. So kind of sum up the way that cities are looking at this is that the city is going to be the first adopter. Almost universally across the board, you're seeing that major cities, Chicago, LA, San Francisco, Seattle, DC, they're the ones who are adopting this technology first. And the larger the population, the higher the economic development, the more likely they are to be working on this. Suburbs and the smaller metro areas are the near seconds and close followers. They have that path for technology and infrastructure to support this. The biggest concern for a lot of us, however, is back to the digital divide issue in rural areas. They're going to lack the budget to truly roll these things out in terms of the roadside technology in the way that would make these vehicles truly operate well. At the same time, there's a question of how much roadside technology is going to be needed in a rural area for a vehicle to operate. And keep in mind that most rural Americans do not want an autonomous vehicle. So back to a city. One more slide down, please. We begin discussing multimodal transportation methods, and a lot of you have seen this stuff hit cities right now. You have personal transportation vehicles like cars and scooters and bikes. Those can become more and more dominant as cities progress, and then you see more mass transit vehicles interoperate, and then you have idealized your cities truly trying to develop more walking areas. There are a lot of debates for how autonomous vehicles are going to roll out in cities. There's some push to have vehicles that are basically in a large garage, and you call for one when you need one. It will drive you where you need to go, and it will go home. You won't own a car anymore. You'll just simply rent for that ride share or that ride that you're going to have. Go ahead and go down to the next one. Slide. Perfect. This was a concept for a multimodal transit center from Uber that came out back in 2014, and it doesn't actually feature autonomous vehicles. But I still thought it was interesting, in which they featured the different mobility points here, and it can be very easy to see these swapped out for autonomous vehicles instead of non-autonomous vehicles. Micromobility in a city is becoming a critical point. It's one of the reasons that scooters were so important to a lot of the areas that truly thrived on them, like San Diego, because they were able to get you that last mile without becoming a headache. However, in cities like Wichita, where it's very car dependent, scooters have a different use case and a different need, and there's other downsides to them. So, more onto the question of why do cities care, which is next slide, please. We care greatly about autonomous vehicles because they improve safety. They can lead to improved economic development. They can also reduce traffic and road congestion, which decreases the amount of lane miles that need to be paved. It also decreases the amount of maintenance that needs to be done. The less vehicles on a road, the less vehicles driving on the same roads over and over again reduces the amount of damage to the roadway. Most autonomous vehicles are electric, and there's currently different patchworks of bills, and both at the city level, county level, state level, and I don't think federal level currently, to insist that any autonomous vehicle in that area is electric, which does lower emissions and pollution, provided that you're not getting your energy from burning the same pollutants as you would in a car, which is gas powered. And then of course that reduced roadway costs that we just spoke of. So what's next for cities as we look through this is trying to develop a way that we will move forward to support autonomous vehicles, move forward in a way that we can install the infrastructure as quickly and efficiently as possible in a way that stewards our citizens' money most efficiently, and be able to develop this technology while also ensuring the technology benefits the average current consumer who's in the current vehicle. Every signal that we've updated, while it has the ability to talk to an autonomous vehicle first and foremost, it currently has the ability to make the life of the individual driver behind the wheel better by ensuring that they're able to have quicker transit times to and from the locations they care about. Next slide. So thank you everyone for your time. I will take questions at the end like everybody else. And if you'd like to contact me, my email's at the bottom of this slide. I appreciate everyone. Thank you so much.
And thank you so much, Michael. What a great presentation. We always learn so much during these seminars. So folks, remember, we will take questions for you at the end. But before we move on to our final presenter, we have another poll question for you to weigh in on. Please enter your answers now. Okay, so here's the question. In a March 2020 AAA survey, what % of drivers said that they would feel comfortable riding in a fully self-driving vehicle? Here are your answers. A, 7%, B, 12%, C, 49%, and D, 64%. So I'll give you just a couple seconds there to mark your answers, and then we'll just, while we're doing that, go over a little bit of what Michael was talking about. So interesting that for these autonomous vehicles, so much work to do. So we don't really think about all the work that goes into it, but boy, there's so much work. So he mentioned cities would probably be first to get those kinds, suburbs, rural areas, of course, have the challenges out there with some other things, so they would be last. And it's so interesting how much work goes into it, like for the whole city of Wichita, that you've got to look at the lights, you've got to look at the infrastructure, you have to look at the sensors. And he mentioned, as we use a lot already today, 5G will play a big role. So looking forward to our next presentation. In the meantime, let's see what the answer is to that question. So we asked you, in the March 2020 AAA survey, what % of drivers said they would feel comfortable riding in a fully self-driving vehicle? And the answer is B, 12%. So it looks like we have a little ways to go on that to get people to feel a little bit more comfortable. Moving on now to our last presenter, last but not least, of course, Randy Barth. Barth is a Senior Government Transportation Safety Account Representative for 3M, where he has been since August of 2004. His responsibilities include reflective sign sheeting, pavement marking, and related services for state and local accounts in Kansas, Missouri, and also Iowa. Previously, he spent 14 years with the Goodyear Tire and Rubber Company. He graduated from Washburn University in Topeka With a BA in Communications, let's now welcome Randy Barth. Hey, Randy.
All right. Thank you, Felicia, for the introduction. And thank you to Wichita State and AAA for offering this opportunity, and pleasure to be here. So we've talked a lot about technology in the vehicle. I'm going to talk a little bit about technology in the infrastructure itself, mainly pavement marking on the roadways, and how wet reflective pavement markings actually help enhance that for the human driver and the autonomous or smart vehicle, as we might be talking about. Next slide, please. So a little background here on my little corner of the world within the 3M's Transportation Safety Division, inventing the reflective traffic sign in the late 30s, all the way up to today, and using that science to improve pavement marking visibility at night in the rain. Next slide, please. So our division, obviously, signing, mentioned pavement marking, also temporary traffic control devices, making them brighter, longer lasting, more durable, in the roles in helping bring families home safely. Next slide, please. So basically, pavement markings must be visible both day and night. And you can see the pictures side by side here of the same roadway. At night, all those visual cues are gone. Any of us driving at night recognize that. The U.S. Department of Transportation recent study, stating pavement markings are one of the most important traffic control devices. They provide continuous information to road users, to the roadway alignment, vehicle positioning, and other important driving related tasks. Again, those visual cues, very important. Next slide, please. So pretty simply stated, driving at night in the rain is a big problem, and I'll kind of start with a rhetorical question. How often have you driven at night, it starts raining, and the lines on the road disappear and you can't see them? Next slide, please. In 2017, nearly 7,000 people, 6,952 people died in crashes on U.S. roads when it was raining. Next slide. So 55% of those fatalities, 3,800 of those deaths occurred at night or in low light conditions. Over half those fatalities, that's equivalent to closer to 1.5 commercial airliner crashes every month. Next slide, please. And only 25% of travel occurs at night. That's a disproportionate spread of those crashes and fatalities. And the data is clear. Driving at night in the rain is a big problem, and these two conditions, rain, are over-aggravating factors in crash risk. Next slide, please. So why wet reflective pavement markings matter? Quickly, I'd kind of like to go through and provide why pavement marking visibility in all weather condition matters, and let's place ourselves in the driver's seat on this next slide, please. So I'd mentioned earlier visual cues being important, and when they all disappear at night, it creates issues. So what do drivers see? On the left, that photo, daytime dry, the middle, nighttime dry, and on the right, nighttime raining. These are all from the same turn lane in California, but different lighting and atmospheric conditions. On the left, the left line, the yellow line, you'll see it's the only fully visible in all three conditions because it has all weather technology in that pavement marking to make the marking visible day and night. Next slide, please. So what happens when pavement markings disappear? Well, obviously reduced visibility, increased discomfort for the driver, less effective lane guidance, increased crash risk. I'll say my daily driver vehicle that I drive for work is a 2019 Toyota Sienna, and it has lane keep guidance system in it, a camera, and it does an amazing job of keeping the vehicle in the lane, beeping, and will even bring the car back to center a little bit if it bumps up on the edge line or the center line. But like many and all the vision camera guidance systems for these vehicles, at night when it starts raining, it has difficulty finding those lines on the road. And in 2016, the European Road Federation concluded in a multi-year study that found when markings aren't visible at night in the rain, driver visibility is reduced and driver discomfort is significantly increased. And it's kind of intuitive. We've all kind of experienced that likely driving at night. Next slide, please. So the research out there is linking wet reflective pavement markings to helping reduce crashes. This study from Federal Highway conducted in 2015 found, as you can see, a 46% reduction in run off the road crashes on multi-lane roads, 41% reduction in crashes with injury on multi-lane roads, and a 12% reduction in crashes with injury on freeways. Next slide, please. So the additional research conducted, Texas A&M's TTI, their study concluded, this was presented at a TRB meeting in 2019, 32% reduction in wet night crashes, 49% reduction in wet night fatalities by using wet reflective pavement markings. And it's intuitive to say that while it helps the human driver, it's going to help the connected vehicle that has camera vision trying to find those lines at night in the rain as well. Next slide, please. So not all pavement markings are created equal. We're going to show a short video here next, but in this video, it's going to talk about refractive index, and it can get to be a deep dive in science, but basically, refractive index is how much that optic in the pavement marking actually bends the light, because there's actually an optic in the pavement marking that returns the light from the headlights in the vehicle back to the driver. So next slide, and play that first video, please. Well, I'm not hearing the audio. I don't know if anybody else is hearing the audio, but it's describing how the light from the vehicle goes into. There we go.
But how effective are they in the dark? Newly installed markings with 1.5 index glass beads offer initially acceptable retroreflectivity. Under dry conditions, markings with 1.9 index microcrystalline ceramic beads are more effective than 1.5 index optics. Optics with microcrystalline ceramic beads also retain retroreflective performance over longer periods of time, on average, than conventional glass beads. However, when markings with 1.5 or 1.9 index optics are covered with water, most of the light that should be returned is instead scattered, making pavement markings difficult to see in rainy conditions. Pavement markings difficult to see in rainy conditions. Optics 2.4 microcrystalline ceramic beads from 3M provide true wet retroreflectivity.
Hey, Maddie, if it's going to struggle to go ahead and run, we can skip to the next slide. I don't think we all want to sit there and watch a video buffering. That's like everyday work in my household. We've haven't been stuck at home since April in quarantine. We've maxed out the bandwidth in our household for sure. I'm sure everybody's experiencing that as well. Let's see if we can go to the next slide here. There we go. So optics in the pavement markings return light back to the source, and that's basically what that video does. As you see here, there's actually couple different size optics, and it's in a yellow pavement marking. But if you've seen any of the striping operations moving down the road, they're spraying a liquid pavement marking, whether it's a paint, epoxy, polyurea, thermoplastic, whatever it is, they're putting down, and then these beads are dropped into it. And those beads have to set in the binder, and then the light from the car hits the bead and returns to the driver, and you can actually see the line at night. If you're looking at a line at night and you can't see it, likely no beads left in it to be returning light to the driver. Next slide, please. So when light travels from air into water, the direction changes. This is called refraction. You can see this picture here with a pencil dropped in a glass of water. One of the analogies I've used often is when my oldest daughter was younger, she had a fish tank, and inevitably there's a fish floating upside down in it. You go to pull it out and it looks like it's a 3-inch long fish, and you pull it out and it's only 1.5 inches long. So water changes things. It changes light, and it changes, we talked about refractive index, which is how much that bead can bend the light back to the driver. It changes that as well. Next slide, please. So I talked about 1.5 being the most common bead, but basically, as this drawing shows, it's light hits the bead bends the light and turns it back to its source. Next slide, please. Now it's showing a 1.9, basically a little bit brighter. It's bending the light a little bit more, getting more light back to the source, the headlight, and to the driver to make that pavement marking, that optic, brighter. Next slide, please. And it's showing a 2.4 here. This one only works when it's wet. If you can hit the next slide, it should bring all the markings or all those bead drawings back up. So basically, to make a system like this work that's wet reflective, you have to have dry beads, a 1.5 or a 1.9. In this case, a 1.9's most optimum, and a 2.4. Put those together, the lines reflect before, during, and after the rain. So those 1.9's only work when they're dry. The 2.4's only work when they're wet. A 1.9, when it gets water on it, it's out of focus. It can't return the light back to the source. It diffuses it. The 2.4's are out of focus when they're dry. They're only in focus when they get water on them. Next slide, please. And we can go to the next slide because we're talking about what to consider when building a wet reflective specification. So that slide would be pointed at the agencies out there talking about this. But basically, there's a couple different ASTM test methods out there. This is organization does a lot of things in our industry. And wet continuous or wet recovery. Basically, can you see the line in a driving rain, frog choking rain? Is it really, really coming down? And wet recovery is how fast does that line come back to visibility as the water runs off of it? Ideally, you want a pavement marking that you can see all the time, before the rain, during the rain, and after the rain quits and the water starts to run off. Next slide, please. So I mentioned a couple studies earlier. This is a recent one, a new one. It says in this slide, final report to be published this month. It's actually been published. This was conducted by Minnesota DOT and Texas A&M's Transportation Institute. And Minnesota was looking, they didn't have a minimum what visibility standard for their pavement marking, and they needed to determine the driver needs and come up with a number that to find a recommended level that would meet a minimum that would take care of the driver, and then use that to justify statewide standards for where and when they use what reflective pavement marking. Next slide, please. And this is another video that I think we'll skip, judging by the buffering that was going on with the first video, and that's okay. I think the links to these videos will all be up on the website for the seminar, and you'll be able to look at them there. That's just showing the different products we use that wet reflective technology in. Next slide, please. So the basic takeaways from this are rain and light conditions are aggravating factors in crash risk. Not all pavement marking optics have the same performance capabilities, and at night during rainy conditions, non-wet reflective pavement markings just can't be seen. And this is important, especially in this setting, as we're talking about automated vehicles, connected vehicles, vehicles with camera vision systems like the one I drive every day. It's picking up those lane markings and helping guide the vehicle. And what we found through our research is the best thing we can do for the human driver is also the best thing we can do for the connected vehicle. And while it's got a lot of technology that might help it react faster than the human can react to changes in that road environment, if it can't see the line, it's just like our eyes. If we can't see it, the technology in that vehicle won't be able to see it, and then we lose the value of those added safety devices in the vehicle. And that's my last slide. As everybody was saying, we'll take questions here at the end if there's anything specific somebody would like to ask. Thank you.
And thank you, Randy. We sure appreciate it and loved your report. Very educational, of course. And now, folks, we want to thank all of our speakers that we heard from today, starting with Rebecca Still with Toyota North America, talking about cybersecurity. Joshua Vandensberg from AAA National Headquarters, who touched on sensor systems and spoofing and key fobs, the vulnerability of technology. Michael Barnett from the city of Wichita, how a city needs to get prepared. So much work to go into before that can take place. And then we just heard from Randy Barth with 3M Transportation Safety Division about the visibility and how important that is. I never even thought about that, all the pavement markings and the optics in pavement markings. And as he mentioned, we'll have those videos that we weren't able to see on the website, and we'll have that website for you up in just a moment. In the meantime, though, it is time now to take questions. So we hope you have some. Go ahead and go to the chat box and put in the questions that you might have, and the panelists will answer those for you. In the meantime, we have a couple of questions that we came up with that we thought that you might want to hear the answers from. And we'll start with all of our panelists. We would like for all of you to try to answer this question. With regard to fully autonomous or self-driving vehicles, in your opinion, what will be the biggest benefit to society? And B, what will be the biggest challenge to reaching full implementation on our roadways? Rebecca, we'll start with you.
Well, as the policy person, I'll take the challenge part first. I think that the policy is going to be the biggest, it could be the biggest impediment to seeing these vehicles in the US. We don't have a federal framework. Right now, you can't deploy AVs at mass scale at all based on how our laws are in the US. So that could be a huge impediment to realizing that technology here in the US. The benefit that I'm most excited about, obviously, is the safety benefit. We lose 40,000 people a year on the roads, and like 97% of those are caused by human error. So really, really excited about the potential for life-saving safety benefits from connected and automated vehicles.
I would tend to agree. I think there's a huge reduction in potential traffic safety accidents with autonomous vehicles. And There's options for increased mobility for people who have challenges getting around, such as people in wheelchairs or the elderly. I do agree that the legislation is going to be an issue, especially when we look at from a state to state requirement. So it's important to have something that covers the entire country. There are currently vehicles testing with this technology now in limited use cases and markets, but it's going to take a lot to get full deployment.
I'm going to mostly agree with Rebecca and Josh in that I do believe policy in the United States in particular is going to be a very large difficulty, especially when you consider our current national political structure that we have. The other thing I think is going to be a huge difficult point is the ethics of these vehicles and how we integrate ethics into their design. I think it's an overlooked point that we need to spend more time on. And what I mean is, how do vehicles handle situations that we as humans have trouble determining? We're going to see a rise in the need for those kind of decisions to be made and integrated into technology. I am, very much excited about the safety components of this in terms of the reduced fatalities and injuries that leave people permanently disabled. And I'm also very interested in the time savings to myself. As somebody who lives relatively out in the middle of nowhere and commutes into and out of work and spends a lot of time in vehicles going to and from meetings, that's ability and time that I could recapture and use in other ways so I don't have to drive.
I think I'd agree with certainly with all the safety aspects. I mean, the opportunities to reduce crashes and then reduce fatalities on a vehicle that could react quicker than the human can to change an environment, avoid a crash. And policy certainly is the biggest challenge. And I'd kind of focus it in my little corner of the world is policy on pavement marking. Federal highway allows everything from 4-inch wide, for example, centerline markings to 5-inch, 6-inch a lot of states. And that skip cycle, the gap in between those skip dashes going down the road, it's different typically in every state, and some states have differences within their own borders. And from what we hear from the automakers is they need uniformity, because that vehicle, the computer system in there is collecting data and it's flushing out the noise, trying to figure out what's a pavement marking, what's an edge line, what's a center line, what's a shadow from a power line up above, what's grass growing in a crack on the ground, and being able to determine, yep, that's lane, this is the lane I'm supposed to be in, and give proper lane guidance.
Well, just to piggyback on what Randy said a little bit, really hit home for me in your presentation. We say it all the time, what's good for human drivers is good for automated vehicles. Consistency and signage, and road striping, and those are things that we can work on today that aren't complex policy issues. It's complicated to get everyone on the same page, but the goal that we're working towards is fairly clear. So really appreciate, everyone in this space is kind of working towards that helps human drivers today and our advanced vehicles in the future.
One more thing I'll add, and that our viewers may not be aware of, is the reason why we have such disparate regulations in the United States regarding this is because the federal government does not actually have currently the authority to regulate vehicles and roadways across the country. We rely on incentives to do it from a federal standpoint, i.e. money. They basically bribe states to comply with the Uniform Traffic Code in order to get federal highway funds. And the states will agree to it because they need the money to build out better highways. But that does result in a patchwork because there isn't a unified legislative source.
Policy, again, it's important.
All right, thank you guys so much. Appreciate it. We do have a question coming in from the audience. Here's the question. With regard to lane markings and their perception by autonomous vehicles, how will that work in rural areas in many cases which may have dirt or gravel roadways with no striping or markings? It's probably for you.
No, great question. So I think what you could see from some of the presentations is think about the redundancy in the vehicle. You've got you don't have one primary system doing everything. I kind of think of it as you know, an airliner, or even as complex as the space shuttle and systems going into space. If one system fails, there's 2, 3, 4 different backup systems in there to keep, you know, that aircraft running. Same thing's going to happen with autonomous vehicles. If the marking's covered up by dirt or snow, you know, some other gravel on the road, something that covers it up, it's got GPS systems to triangulate and get it home. It's got LiDAR recorded data of that roadway to hopefully be able to keep it aligned and keep it going. And quite honestly, it's gonna be a long time, I think, until we don't rely on the human sitting behind the wheel as an extra safety benefit. You know, we talked, Rebecca mentioned on all the crashes per year, and 97% of them are human error likely. We're not going to eliminate the human error. The autonomous vehicle is trying to help reduce the opportunities for the human to make that error to cause a crash.
And in some of these cases, we talk a lot about seeing connected autonomous vehicles in dense areas, because that's the more complicated environment. A more rural environment is not as complicated for an autonomous vehicle or an automated vehicle to operate in. And so I think that while a lot of focus is on what's happening in San Francisco or New York City, you know, Toyota, we're really thinking about how do we bring mobility to all, and that doesn't just mean people that live in San Francisco. And rural areas represent a huge opportunity, and they're quite simply easier to navigate than a complex city environment.
And I kind of, to piggyback on that, the other piece of that environment that changes is a work zone. So you get into the construction season and suddenly all the mapping gets blown out the window, because now there's 3 miles of channelizer cones going down the road as they're doing construction or a bridge project. I mean, something that changes the environment temporarily.
All right, so much to think about. Got another question for you guys too. Has anyone thought about necessary redundancy for CAV systems? Electronic will fail. How will this be addressed?
Do you want to take that one, Josh?
Sure. So a lot of these automated vehicles, they do have redundancy built into a lot of these systems. So there's backup redundancy for brakes, and there's backup for steering, and they have it designed in where if one critical system fails, the vehicle goes into like a limp home mode to safely get it to a static state. So in addition to redundancy in sensor systems, so it can see if it's raining or snowing, there's backups in critical vehicle powertrain systems to make sure that if one system does fail, the vehicle is able to accommodate that and safely get the occupants back to safety.
Hey, anyone else on that one?
What Josh said.
All right.
Ditto.
All right, thank you, Josh. Okay, here's another question, guys. Perhaps this is best aimed initially at Michael with the city of Wichita. So, Michael, with budgets often a challenge at the local state level, what sort of investment will be needed to make a fully autonomous transportation system possible, and where will those dollars come from?
That's a fun one. See, you know, budget is always going to be the largest concern when it comes to technologies like this. The budgets come from a number of different sources. For a lot of cities, it's going to come out of CIP funds, capital improvement funds. We bond those out for many years. So cities that have a better bond rating are going to be able to put this out for a lot less expensive. City of Wichita has one of the best bond ratings of any city in the country. So we do have benefit to borrow money for a very, very low amount. And we are able to build these systems out for a very, very small amount of money. Comparatively speaking, of the long term. When we talk about the total cost, it's going to be expensive. And the issue there is that it's not just expensive because it's the capital cost, the cost for infrastructure, cost to install new traffic signals, to install new controllers. You might be looking at a city of Wichita size between $30 and $50 million to replace that system out. But the true expensive part is going to be on the people side, the analysts you have to hire, the traffic engineers, the IT analysts to control the systems, data input and data outputs. And then on the maintenance folks who are going to have to go out in the middle of the night and repair that signal once a resident who is not autonomous drives over the traffic box, which happens more often than we'd like to admit. Anybody else?
I think part of it too, right, as how are we making these investments now? And you were talking about, DSRC, and there's a whole debate going on right now around what do we do with the spectrum that was originally set aside for DSRC, and cities have made massive investments in these systems already. And so in that policy area, looking at where investments already been made and not trying to go backwards and figure out how are we going to be tacking on other V2V, V2X types of communications when cities are on really tight budgets already. So it's a policy consideration as you're thinking about different requirements for connected infrastructure.
Well said.
All right, everyone. I think that's about all the time we have for this morning. I want to thank everyone for taking time out of your Friday morning to join us. Wichita State University, AAA Kansas, we thank you for the thought-provoking questions, of course, out there. And thank you for joining us for this latest Technology Takes the Wheel, Connected and Autonomous Vehicle Seminar Series. This was our third one, and we appreciate everyone joining us, all of our panelists, and of course, all the sponsors. So we want everyone to have a great weekend. And remember, you can get the information, you get this whole webinar if you want to see it again on the website, and as well as Randy's videos that were shown today. And I think we're going to put that video in that website up for you. But it is www.wichitastate.edu/research/WSU. So start there and you can find that video to the webinar for today, as well as the other two. All right, again, thank everybody for joining us today.
Thanks.
Thank you.
Thank you, everyone.